Hello, welcome to the second set of our stoichiometry revision questions. The first set was focused on more basic calculations, whereas this set will be a bit harder and focus more on application questions. It will once again be split into two separate parts, with the first part focusing on questions that you will typically find more so in an examination. For the first question, it states a 1.2 gram sample of impure sodium carbonate is dissolved and allowed to react with excess aqueous calcium chloride, CaCl2, and the following chemical reaction takes place, with the equation stated as such. The resulting calcium carbonate precipitated was filtered off, dried, and found to weigh 1.001 grams. Assuming that the impurities do not contribute to the mass of the precipitate, calculate the percentage purity of sodium carbonate in the sample. If you recall what I mentioned regarding the section of percentage purity, whenever the question gives you both the mass or the amount of both the product and the reactant, it should automatically ring alarm bells because technically they only need to give you the mass of one if complete reaction were to take place and if the reactant was 100% pure. So as you can see in this case, because they give you both the product and the reactant, the mass of both, it is a percentage purity question. Now to keep up the good practice, we will need to highlight all the important information. So the masses of both the products and reactants, and the fact that calcium carbonate is your precipitate. Here the question is kind enough to give you the equation, so we will not need to derive the equation ourselves. Firstly, we can't use the mass of the impure sodium carbonate to find the amount of sodium carbonate because we don't actually know the exact mass of sodium carbonate in this impure sample. Instead, we have to use the mass of the calcium carbonate. So let's find the amount of calcium carbonate formed, which is equivalent to, if you have your calculator with you, it is equivalent to 1.001 grams divided by 40 plus 12 plus 3 times 16, as that is the molar mass of calcium carbonate, which will give you an answer of grams per mole. It will give you an answer of 0.01001 moles. We can now use this and the equation to find the amount of sodium carbonate. The amount of sodium carbonate, which is Na2CO3, is equivalent to 0.01001 moles. Multiplied by 1, since the mole ratio of calcium carbonate and sodium carbonate is 1:1, so you just multiply by 1, gives you 0.01001 moles. So now, to find the mass of sodium carbonate, you have to multiply the amount or the number of moles by its molar mass, which is 23 times 2 plus 12 plus 3 times 16 grams per mole, which will give you an answer of, if you punch this into the calculator real quick, you will get an answer of 1.0611 grams, since this is to 5 significant figures. And your percentage purity, if you remember the formula, is the mass of your pure sample, 1.0611 grams divided by 1.200 grams times 100%, which gives you an answer of 1.0 10611 divided by 1.2 multiplied by 100 gives you but rather high percentage purity of 88.4%. 3 significant figures. So this question is a nice warm-up question because it is not super challenging, but it is definitely harder than the basic foundational questions we did in the first set of revision questions. Here, percentage purity is quite simple and straightforward. We just have to find the mass of the pure sample, compare it to the mass of the impure sample, and multiply that by 100. Moving on to the next question. 3.8 grams of an unknown salt of the chemical formula M2SO43, where M is a metal to be identified, were dissolved in water. Firstly, I'd like to point out the charge. So it requires 2 ions of M to react with 3 ions of SO4, 2 minus. So since SO4 2 minus has a charge of 2 minus, and you multiply that by 3, the total negative charge of this molecule is actually, this ions is 6 minus. So that means M2 must contribute 6 plus. That means M is actually has a charge of 3 plus. So there's some minor information you need to pick up when you're writing, when examining the question. To continue, all the sulfate ions were precipitated by adding excess barium chloride, since barium sulfate is insoluble, and it forms 7.77 grams of barium sulfate. How many moles of the unknown salt were in the solution? So here we will need to write out the chemical equation. So that's always a good start. You have M2SO4 3 equals plus barium chloride equals as well to give you barium sulfate it's not equals, but it is a solid, since the question says that it's precipitated, plus what is going to be, here's a bit tricky because you need to balance the charge. Remember that M has a charge of 3 plus, Cl has a charge of Cl minus, so it's going to give you MCl3, and we can assume this to be equals. Now we need to balance the charge. So as you can see, you will need at least to put 3 here. It's okay to do trial and error, but we shall do simple observation first. Since there are 3 sulfate ions on the left, there must be 3 sulfate ions on the right. So we need to put this here as well, 3. So you have a total of 6 chloride, and you need to put 2 in front here to cancel out the 6 chloride. And thankfully, the number of M on both sides is 2. So this is your balanced equation. The question asks how many moles of unknown salt were there in the solution. So we need to find the amount of barium sulfate first. So for part A, amount of BaSO4 is equivalent to 7.77 grams divided by the molar mass. Barium, the molar mass is 137 plus 32.1 plus 4 times 16 grams per mole, which will give you a total number of moles as 0.03333 moles. Once again, we round this to 5 significant figures. Yep. So now let's continue from here. The amount of unknown salt, which is M2SO43, is going to be 1/3 of your 0.03333 moles, because the mole ratio here is 1:3. So to continue, 3 moles divided by 3 to obtain 0.01111 moles, which is equivalent to 0.0111 moles, rounded to 3 significant figures, as your answer should always be the 3 significant figures. Calculate the relative atomic mass of the metal M and identify it using the periodic table. So, to recap, before we start on B, to find number of moles, which we shall call amount, it is equivalent to your mass over molar mass. To identify the relative atomic mass, we basically want to find molar mass, which would mean we need to divide the mass by the amount. So, to find molar mass of M2SO4 we divide the mass 3.80 grams by 0.01111 moles. Tidy this up a bit, and you shall receive an answer of 3.8 divided by 0.011111, 342.000 grams per mole. Once again, your answer should be to find SF for intermediate working. To find the AR of M, we simply have to take 342 minus 3 times of 32.1 plus 4 times 16 and divide this entire thing by 2 to find the AR of M. So that will give you an answer of 26.850. Once again, to 5 significant figures, which we can then round off to 26.9, since relative atomic and mass is always to one decimal place. And you realize, if you check the periodic table, that M is aluminium, because we can match the relative atomic mass of 26.9 to the relative atomic mass of aluminium, which is exactly actually 26.9. So that will be how you solve this particular question. Next, an unknown carbonate of chemical formula M2CO3, where once again N is an unknown metal, is treated with hydrochloric acid to liberate carbon dioxide. Upon treating 2.65 grams of this carbonate with excess hydrochloric acid, so basically all the carbonate will react since hydrochloric acid is in excess, it is found that 560 cm3 of calcium carbonate is liberated at room temperature and pressure. Here it's important to note that it's room temperature and pressure, since that will affect your molar volume. Calculate the percentage by mass of the metal M in the carbonate. So, as group practice, we will always have to write the equation. So M2CO3, and once again you will realize that since CO3 has a charge of 2 minus, that means the charge of M2 must be 2 plus, so M has a charge of plus. To continue, here these symbols are not really important, so we can skip it. You react with hydrochloric acid to give you MCl. The reason we know is Cl and not Cl2 is because M has a charge of +1. So it's important once again to always write out the key information. Carbon dioxide plus water. Since there is 2H on the left hand side of the equation, 2H on the right hand side of the equation, we simply write a 2 here, and your entire equation will be balanced. 2M and 2Cl on the left and right hand side, CO2 on the left and right hand side of the equation, and an extra 2H and O on the right hand side of the equation and left hand side of the equation. So here we will need to find the amount of carbon dioxide at room temperature and pressure. So the amount of CO2 is equivalent to 560 divided by 1000, because you need to convert it to dm cubed before you divide it by 24 dm cubed per mole to obtain number of moles as 0.023333 moles to 5SF. So to find the amount of carbonate, we have to refer to the equation and use the amount of carbon dioxide to assist us as well. M2CO3, you have 0.023333 moles times 1, since the mole ratio thankfully is 1:1. So this will continue to be 0.023333 moles. Okay, so let's find the molar mass of M2CO3. So molar mass is equivalent to, if we follow the formula just now, 2.65 grams divided by 0.023333 moles, which will give you an answer of 113.57 grams per mole to 5SF. Now we need to find the AR of M, which would be equivalent to 113.57 minus 12 minus 3 times 16 divided by 2, since each compound has 2M, and your answer should be 26.785, which is quite similar to that of aluminium in the previous question, but remember that this is not the exact same question, so it's more of a happy coincidence. Now to find percentage by mass, you just have to take 26.785 times 2, since once again each M2CO3 has 2M, and the total molar mass, which is simply 113.57 times 100%, and your answer is 26.785 times 2 divided by 113.57 times 100% gives you a percentage by mass of 47.2%. We rounded off to 3 significant figures for the final answer once again. So this will be how you solve this kind of particular questions.